Hello friends, in this video we will talk about hydrolysis and its various types we will discuss, which are very frequent in use in a biochemical process. So let us talk hydrolysis. Well, as the name suggests, you can see when you talk hydrolysis, well, this is made up of two words, hydro, you know it, hydro and lysis, and you know that this is Greek word for water. Well, this is Greek word for water, and you know when you talk lysis, you are talking breaking. So honestly, hydrolysis is a reaction. Hydrolysis is a reaction of a chemical substance with water Hydrolysis is the reaction of chemical substance with water leading to its breaking. Into two parts, generally into two parts. One part keep H plus and the other part, or you say product, OH minus of water. Okay, so this is quite simple, you know it, you must be knowing, but just for sake of representation, how you will represent, if you have this, what you get AH plus BOH, and obviously this the process you call hydrolysis. Now hydrolysis, why hydrolysis is very important? Hydrolysis mainly occurs in polymers, and you can say, and also biomolecules. And when you talk biomolecules, that is protein, lipids, complex carbohydrates, and other organic compounds. Okay, and the best example is, you can say, ester. So ester is one of the example, and here I will give you the example. You can see, if you have this ester, you know it that this is ethyl acetate. What you have acidic condition, and then you have water. What is happening? You see here, what you get? You get acetic acid, you get acetic acid, and you get ethyl alcohol. So you can see here that in this part you have H is coming here, okay, and here you can see OH is coming, so OH minus this is there. So this is a very brief, rather important definition or whatever you can say about hydrolysis. Another important thing is that when you talk hydrolysis, there are 4 classes of hydrolysis depending upon the substrate and the catalysis used. So you may write or you may study types of hydrolysis. As I told you, depending upon the catalyst, so you have acid catalyzed hydrolysis, just for sake of hydrolysis. Then you have base catalyzed hydrolysis. Then you have enzyme catalyzed hydrolysis. So these 3, you can see that these are the hydrolysis 3 types are based on the catalyst used or the catalyst which affects the hydrolysis. Here you can see it is the acid, it is the base, and the enzyme. And the last one is salt hydrolysis. So what you have, you can see here that here the substrate matter. So 4 type of hydrolysis are most of the time you will encounter in either chemistry or in biochemistry. So next we will talk about acid catalyzed hydrolysis. As we have already discussed, that hydrolysis means reaction of water with a chemical substance leading to its breaking into 2 parts. One will get H plus sign of the water and the second part will get OH minus. That is, you will have 2 products. Now when you say acid catalyzed hydrolysis, so these are hydrolysis catalyzed by acids. When you talk acids, obviously you write like a HA. And what are the common acids? Well, the common acids are used are HCl and H2SO4. Okay, and the most common example of acid catalyzed hydrolysis is of ethyl acetate of an ester. Rather, we will in a general term we will talk that the most common acid catalyzed hydrolysis is of an ester. So let us see if you have this compound OI dash. So this is an ester. So what you are saying? You are saying that H plus and water. I have already, but you will getting this, the corresponding acid and alcohol. You are getting a carboxylic acid, and alcohol, depending upon the value of R dash. Now you see here what it means. It means that the acid catalyzed hydrolysis of esters is a reversible reaction. So this reaction, what we are is reversible. And of course, if the amount of ester is more or water is removed during the reaction, backward reaction is favored. Backward reaction is favored. Backward reaction is favored. So this is a reversible reaction, and when the backward reaction will be favored if you remove the ester and you remove the water. If the amount of ester is more or water is removed, backward reaction will take place. Now let us talk some mechanism. We will talk to have a look how it goes of this reaction. So what you have mechanism here of this reaction. You have the acid from where you are getting your H plus ion. Now you must remember that here water acts as a nucleophile. Okay, so how it goes? Here is your substrate, COO R dash. So in the first step, H plus, you know it. This will be get attached to here, CH3 C-O plus now H O R dash. Okay, and now you see water will attack it. Water will attack here and you get this. So the next step you can show like this. So you have OH OR dash and you have O plus H. Okay. In the next step, now all the time you have to write reversible. You have to write reversible. Here also reversible. Now what will happen? H plus shift will take place. And what will happen? You have CH3 COH OH OR OH OR dash OH plus. Okay, and now here it goes. So what you will have now? You have CS3 CO OH plus R dash OH. You have H plus minus, and this one H plus react with A minus to give you HA. So you can see you have now acid and you have alcohol. So this is the mechanism of acid catalyzed hydrolysis. Sometimes you may need it to understand the mechanism. So you see that here, though the catalyst is an acid, but the water acts as a nucleophile. The reaction is reversible and it favors the backward reaction when you remove the quantity of ester is more or you remove the water. So this is all about acid catalyzed hydrolysis. Thank you.